In today's video, we're going to talk about how you draw organic molecules. There are four main ways that you can do this. They are expanded, condensed, three-dimensional, and line angle drawings. Before we get started, let's just always remember though, so remember the following. Carbon likes to form four bonds. Okay, and that's because carbon has four valence electrons. So when we draw a Lewis structure, okay, carbon is going to have four valence electrons, and a simple molecule like methane, which is CH4, is getting the extra electron from each of the hydrogens to then give the carbon a total of 8, satisfying its octet, and then we have two bonds shared. We would then draw this as C, H, 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 and H. Okay, so that represents methane, and notice that each of these straight lines represents basically a pair of shared electrons. So let's look at a couple simple examples. Let's look at C2H6. Okay, so how would we draw this? Again, I'm going to go through the four different methods to do this. So the expanded form would look like this, where I have my two carbons, and then surrounding those two carbons are going to be the associated hydrogens. So notice that each carbon has four individual bonds. So that would be the so-called expanded form. Now you could condense this in a little bit more condensed way to have the following structure. Okay, it looks like that. So you'd write a CH3 and a line CH3. This is an older methodology that's used, especially if you're writing something on a typewriter or a keyboard. It's fairly easy to write this. As we'll see when they get more complicated, this kind of structure can be sort of difficult to interpret. So that would be the condensed formula. Next, let's look at what the three-dimensional formula would look like. So to do this, we're going to actually use what are called wedges and dashes for our bonds, in some of the cases for the bonds. So what's going on here is that when I use a dash, that means that it's going back, and a wedge is out. So coming out of the plane defined by the glass board here. Okay, so this would be a three-dimensional model. Notice that coming off each carbon, we have a tetrahedral shape of the bond. So the bond angle here is going to be 109.5. All right, so that would be the three-dimensional drawing. And then lastly, the line angle drawing. Now this one is going to look really kind of simplistic. So that's it. If I want to draw this molecule C2H6, I can just represent this now as just a straight line. Again, what does this mean? Well, this point right here would represent a carbon. This would represent a carbon. And then coming off of that would be the associated hydrogens. And because we're all becoming great organic chemists now, we would know that each of those carbons would have its associated complement of hydrogens. All right, in this video, we're going to look at a couple more examples of organic drawing, but we're going to look at a little bit more complicated examples. So to start out, let's draw C3H8. Now this molecule is called propane. And as we discussed in the last video, always remember that carbon is going to form four bonds. So let's draw the four different ways of doing this. So expanded, condensed, 3D, and line angle. So expanded, we would just start with drawing a chain of carbons, and then we put single lines out for each of our associated hydrogens, and then we go ahead and draw those in. Oh, I missed one. Okay, so that would be the so-called expanded formula. Now the condensed formula, we would draw like this. So we'd have a CH3. Now this carbon in the middle, we're going to list that as a CH2 and then a CH3. Okay, so notice that this is a little bit shorter form, and again, this is how you might write it if you're using a keyboard or a typewriter. Okay, so next let's go to the three-dimensional one. Now this one's a little bit trickier because we want to make sure that our carbons have kind of that three-dimensional look to them and have a look that tries to approximate the tetrahedral bond angle of 109.5. I'm going to use these dashes and wedges again. So notice this carbon in the middle. I've got the two hydrogens, one's forward, one's back. Now again, it wouldn't really matter which ones you were to draw, either up or down. Just make sure that you always have one dash and one wedge. And this does take some practice. Some of the problems we're going to do will definitely give you some practice. Now how would I draw this using the line angle formula? Well, that's really easy. You just do that. So when you draw the line angle, what these represent, any end of a line is a carbon, and any change in direction of a line is a carbon. But again, because we're becoming good organic chemists, we now know that each of these carbons has its associated number of hydrogens, but we're just too lazy to actually show them. In this example, we're going to take a look at a little bit longer chain. We're going to look at C4H10. Okay, so this molecule, having 4 carbons, is going to be called butane. One thing, just make sure you're not calling that butane. That's just not the way we talk about it in organic chemistry. So 4 carbons. So if I wanted to draw this now in our expanded form, I would have this, and again, each carbon with its associated hydrogens, and all single bonds between the carbons. Okay, so as we start to get a longer chain, you can see that this definitely gets to be a little bit more of a pain to have to draw out all those hydrogens. That's why the condensed form is kind of nice. So this one, I would now put a parentheses and have it look like that. Okay, so notice the 2 CH2s that are in the middle, I've put those in a parentheses and had a subscript 2 for our condensed formula. Three-dimensional. Now this you can definitely tell, if I have to draw all these carbons in a three-dimensional format, it becomes much more difficult. One way to approach this is to kind of have a sawhorse kind of look to your initial chain, and then add in your dashes and wedges. Again, each carbon is going to have one dash, one wedge, and then 2 lines coming off of each carbon that are going to be in the plane, which we just represent by a regular straight line. Okay, so here's those 2. And again, it will take some practice before you can get to where you can actually make this look sort of three-dimensional. It's trying to approximate that 109.5 degree bond angle. Now, when I draw the structure of this one in terms of the line angle formula, this is quite easy. So here's now my butane molecule in this straight chain form. Now butane, as we'll see, you can have an isomer of butane where I'm going to move one of these methyl groups onto this carbon, and it still will adhere to this formula, C4H10, but I'm going to draw an isomer. So now let's draw the isomer of regular butane that adheres to the same formula, C4H10. So to do that, if I wanted to draw this in the expanded form, essentially what I'm going to do is I'm going to take one of those carbons that was in the straight chain and move it so it's now a branch coming off of the main chain. And if I now add in my hydrogens, I get this. And notice this middle carbon now has 3 of these CH3s attached, and then just 1 hydrogen coming off there. Now if I wanted to draw this in the condensed formula, look like that. Now notice this, again, is a little bit confusing. The CH3 here in the middle, it's not attached to this carbon over here or not attached to the hydrogen. The CH3 is actually attached to this carbon right here. So that's a little confusing. It does take some practice, but that's what the condensed formula would look like. Three-dimensional, I would have something that looked like this. Okay, so one of these carbons coming off is actually going to have a wedge to it. And then I would add in my hydrogens on the other. Okay, again, you can see why using this three-dimensional form does create a little bit more complexity, especially as we start adding carbons. But this still does adhere to this molecular formula, C4H10. And then lastly, if I want to draw this using the line angle, it's really quite easy. So I just draw my regular chain here, but now I've got a branch coming off of it. So these molecules, I drew, the first example, I drew regular butane. Okay, that's one isomer of C4H10. This is also going to be an isomer because it retains the same molecular formula, just has a different connectivity of the carbons. This molecule will be called 2-methyl propane. And in some of the videos coming up, we're going to talk more about organic nomenclature, how you would name those. So these two are then related as isomers. And again, the definition of an isomer is two molecules that have the same molecular formula, but a different connectivity of their atoms.